All right, so we're going to go through the warm-up pretty quickly so that we can get into our lesson for today. All right, number one, given point B is between points A and C. That's where we're starting, something that I definitely want to point out that I saw happen on the test. They did not tell me that B is the midpoint. So I cannot say that segment AB is congruent to segment AC because B is not the midpoint here. What I can say is that the two smaller segments, their lengths, so AB and BC, together, those two make up my long segment from A to C. Then I'm going to fill in what they gave me. So from A to B is 3x. From B to C is 2x. Thank you. One of the biggest mistakes that I saw, and it happened on more than one problem and on lots and lots of tests, we set up our equations wrong because we did not start off with our true geometry statement. You have to get whatever it is that you can say that's true about the picture written down first, and then you can substitute pieces in. So I know that from A to B is 3x, so I can substitute that piece in. I know that from B to C is 2x, so I can substitute that piece in. And then I know the whole thing from A to C was 50, so I can substitute that piece in. Things that I saw a lot of that was really good is we were definitely making some substitutions. The problem was we weren't starting from a true statement. I saw several tests where they told me that BC together with AC was equal to this little segment over here. Please make sure that your geometry statement is set up first and that it makes sense. All right, so from here I'm going to combine my like terms together, 3x and 2x, so I get 5x equals 50, which means x is how big? 10. That was one thing I was supposed to find. It said find x. And then they also asked me to find AC, which was kind of silly because how big is AC? 50. They told us at the beginning AC was 50. Number two, I have a different piece of information to work with. On number two, I can say my smaller segments are congruent because it tells me that M is the midpoint of B and D. So I know now that these two pieces are the same size. If the two segments are congruent, then their measurements from B to M and from M to D are equal. They told me that from B to M is 5x minus 2. They told me from M to D is 3x plus 4. Since M is the midpoint, I know I can set those two things equal. 5x minus 2 is equal to 3x plus 4. We're going to solve this for x. So I'm going to subtract 3x from both sides. So 2x minus 2 equals 4. Add 2 to both sides. So 2x equals 6. And then I divide both sides by 2, which means x is how big? X is 3. Was that what they asked me to find on this problem? No. What did they want me to find? They wanted me to find the length from B to D. Well, I know that segment BD is made up of what two smaller segments? BM and MD. When I put those two smaller segments together, I get that full long segment. So then I substitute in, we have 5x minus 2 in the place of BM. And I have 3x plus 4 in the place of MD. We're going to substitute 3 in the place of the x because we just found that. Five times 3 is 15, minus 2, plus 3 times 3 is 9, plus 4. 15 minus 2 is 13, The other segment is the same size. 9 plus 4 is also 13. So from B to D is 26 units. Once you are done writing things down on your warm-up page, please go ahead and pull out your books, open them up to page 65. Our next test is in 2 weeks. It's the Friday right before we have our long weekend, our Labor Day weekend. So page 65 in your books, please. If you are not, can I go back? Yes, I'm sorry. If you are not in the habit of using colored pencils or using highlighters, I would highly, highly recommend having some on hand for this next module. If you guys thought that the last module was a lot of information to take in, a lot of notation, this one is on par with that. These first 2 modules lay the foundation for what we're doing in geometry. So the first thing we need to do is we need to talk about some new geometric objects, and we need to talk about the proper ways of naming them. There's going to be some examples where I got a whole bunch going on the screen, so I'm going to periodically wipe the pictures of all the colors that I'm putting on here so that it's not too confusing. Right. First thing we need to talk about is a ray. A ray is part of a line segment that has an endpoint together with all of the points on one side of the endpoint. So they have an example of a ray for us here. You can call this ray AB or ray AC. A is the endpoint. And when we are naming a ray, the endpoint is always the thing that comes first. The second point tells me, okay, if this is where I'm starting, if I'm at my endpoint, where do I go from here? Which way should I draw? Which way should I look from here? That's what that second point is telling me. So as long as it's in the direction that I want to go, it can be my second point in the way I name a ray. Our rays don't have to start on the left and only point to the right. Rays can go all kinds of different ways. I can have rays that point to the left. I'm going to call this one M and P. Which is the end point here for the one that I just drew? M. So I would start my notation with M because that's the end point. Right here. And then what's a point in the direction that it keeps on going in? P. So MP, and then I put an arrow over the top of it that only points one way. Notice, in my picture, my ray is pointing to the left, but when I write my notation, we always write it in the same order every time so that we have consistent notation no matter what the ray is doing. We always start with the end point, no matter where we found it, and then we have a letter that's in the direction that we're going after that. Above the letter that is not my endpoint, that's where the arrow part goes. When we do notation for a ray, it's a one direction arrow. The side with no arrow on is my endpoint, always. I can even have rays that point diagonally. If I call this point S and this point Q, how would I name this ray here? SQ, and then the arrow over the top always looks the same for my ray notation. So far so good with what a ray is and how we name it. It's very similar to a line segment, very similar to a line. The difference this time is that the order of the letters really, really, really does matter, because that first letter is your endpoint. All right. 2 collinear rays. What does it mean to be collinear? On the same line. If I put two rays together. They're on the same line and they have a common endpoint. We're going to call A our common endpoint. How would I name this ray? So where I start at A and I go this direction. AC. Or what other name could I give it? And I'm still talking about the same ray. I can't call it BC because that would move my endpoint. My endpoint is still A, so it still has to start with A. And I just need another point that's in the same direction that I'm heading. AB. So I can call it AC or I can call it AB. What about the ray that is on the opposite side, the one that I just drew over in purple? How would I name that one? AD with the arrows over the top. Nice work. First letter is always my endpoint. If I have two collinear rays with a common endpoint, like in this picture, we call them opposite rays. Because I have one ray that's going this way and another ray that goes the exact opposite direction. When I put those two rays together, I get a whole line. Opposite rays form a line. I cannot stress how important it is. If I write it down on the board, you guys need to be adding this into your notes because these are important ideas that come up. Opposite rays together form a line or something that we call a straight angle. An angle is normally something that we think of as having a bend to it. Like I got one side and I got another side. When I have opposite rays, we still call that an angle, but we call it a straight angle. So a line is the same thing as a straight angle. And the measurement of a straight angle is 180 degrees. So from here to here is 180 degrees. Anytime I take two rays and I have them share a common endpoint, we've formed an angle. This one is probably the most complicated one to understand, but the easiest one to draw. I can have an angle even when it looks like a straight line. Look a little bit further down your page. We're now at the bottom part. An angle is a pair of rays. What do we mean by a pair of rays? Two. So two rays with a common endpoint equals an angle. Two rays with a common endpoint. That's what we mean when we're talking about angles. Ways that we name angles. We've talked about how to name lines. We've talked about how to name line segments. Now we've learned how to name rays for naming angles. Oops. We need 3 points, so 3 letters to name an angle. There is a special case where we name with only 1 letter. Or sometimes we'll name it with a number. Those are special cases. I want you guys to practice naming angles with 3 letters. When we name an angle, Just like when we name segments or lines, we have some special notation that goes with it. This symbol right here, it looks kind of like a less than symbol, except it's like a less than symbol that's laying flat on the ground. This is what we use for the angle symbol. When we name angles, the common endpoint will always be in the middle. So if I look at the possible names they gave me here, the ones that are named with 3 letters, what's in the middle of all of them? A, that is my common endpoint. So ways we name angles. I always start with a point that's on my ray, but not the common endpoint. So I don't want the middle. So I can name this DAB, or I can call it DAC. It doesn't matter whether I have B or C because those are both in the same direction. Only 3 letters though. DAB or DAC. Or I can switch that around the other way. I can go the opposite direction. I could go CAD or BAD. The times that I can get away with just 1 letter, if I have a picture and there's only 1 angle shown in the picture, then I can name it with just that common endpoint. We call the common endpoint, because common endpoint gets to be a lot to say over and over, we call that common endpoint the vertex. So that's what goes in the middle of all of my angle names. You can think of the vertex as the pivot point. My angle, when they tell me the name, they tell me where to start. They tell me where to go to next. And then I'm going to pivot. I'm going to change directions, and I'm going to go in a new direction from there. So I start here, I come down, and then we pivot over here. Or I start over here, and I make my way to here, and then I pivot like this. My vertex is the same thing as a pivot point. There are 2 parts to an angle. There's the vertex, which we just talked about, and then there are the sides. The sides are the rays. For an angle, we call the sides the rays. So I really like this diagram down here. The vertex goes in the center. Side AD names my vertex first, and then it tells me which direction to go. Side AB, again, we start with the vertex, and then it tells me which direction to go. What's another name that I could give to side ray AB? AC, yes. That would be the exact same side, exact same ray. We can just give it 2 different names. Flip the page for me. There's one last idea that we need to talk about. Points D, A, B, and C. Those are on my angle because they are making up part of the rays that form my angle. These points in here, it looks like my angle looks like this. My angle could hug those points. Those are on the interior of the angle. These points back here, we say they are on the exterior of the angle. So if I have my angle, Any points that my angle could hug, because it looks like it's coming around it. It's less than a straight angle, because I came in. Those are my interior points. Any that are on the opposite side would be exterior points. If I have a straight angle, so opposite rays, there is no interior or no exterior. I can only have that when I have an angle that's not a straight angle. So if I had an angle that was going like this, these points would be on the interior, and all these others would be on the exterior. Let's look at example number 1. There's a whole bunch going on here. And if I'm not mistaken, what's in my book is, what's up on my screen is a little bit different than what is in your book. Is that correct for part A? Does yours look a little different in your book? Some of it's the same and some of it's a little bit different. Like, do you guys have all the numbers there? Not all of them, but some of them? Okay. So I'm going to write this down a little bit differently. What's in your book is still a good place for us to start. And in fact, here we go. I'm going to do a lot of writing off to the side. They got us started with these angles right here. I want to look at them one at a time, and we're going to name all the other angles that are that exact same angle. We're also going to name every single angle in this picture that has D as its vertex, D as the center point, the pivot point. So this guy right here is the one that we're looking at. He has to be in the middle of everything we're talking about. This is where I'm going to end up with way too much drawing on the screen. So I'm going to try to go through things a piece at a time. When it gets to be too much, I'll erase it. Or if you think it's getting to be too much, ask me to erase it, and I'll start over on that part. All right, so the first one that I have on my screen is angle EDF. Angle EDF. Where's E in the picture? Up at the top. So E, then I come down to D. That's my middle point, my vertex. And then where's F? Off this way, off to the left. So this angle that I have in red, I'm ignoring all the other lines and points, or all the other lines, not all the other points. Ignore all the lines except for these two rays. What is another name that I could give to this exact same angle? Sylvia, and then nope. Side what? Side DE with, oh, I see what you're saying. Those would be the pieces that make up my angle. So if I asked you what are the sides of this angle, you could say ray DE. Yes. But I want another name for this angle that I have in red. Yes. We could call it angle 7. Yes. This is one of those situations where we could name it with this little number right in here. I can only do that when there's only one angle that meets that criteria. In this case, that's 7. There's nothing in the interior there. There's nothing splitting that into pieces. So that whole thing I could call angle 7. What is another point that's in the same direction as DF? What's another point that's in the same direction as DF? B. B is in the same direction. G is on the opposite side. We'll talk about him in a minute. But point B is in the same direction. So I could also call this angle EDB. So EDF, EDB, I'm moving in the exact same ways. Would it be the same angle if I went backwards? If I started over here and then went this way and then up? Would I be talking about the same figure on here? Yes, so if I went backwards, what could I name it? FDE. So angle FDE. If I can call it EDB, what would it be called if I turn it around? BDE. Angle BDE. Those are all names for this same angle right here. EDF, EDB, FDE, BDE, or angle 7. That's a lot of names for the same angle. Leo, I need you to head up for me, dear. This is super important stuff. You got to stay with me. Angle EDG, this is the next one they gave us here. Angle EDG. So now I'm starting in the same spot that I did before. I'm coming down to D again. And I'm heading off in this direction. So from E to D to G. What's another name I could give to this exact same angle? I could call it angle 8. I see one other name that I could give it. GDE, angle GDE. All right. FDC. Are you guys okay if I erase the blue and the red so that there's not so much on the screen? I'm afraid if I get too much more on there, it's going to be really confusing. All right, so now it's telling me to start at F. That's over here. My vertex is D because it's in the middle. And then I'm going to come down here in the direction of C. So I have this as my purple angle. Angle F, D, C. What is another name that I could give that purple angle right there? I could call it CDF. I can call it angle 6. I see two more names that I could give this. CDB, angle CDB. Or if I turn that one around, I can get the last one, BDC. All right. Angle GDC. So GDC. What's another name that I could give to angle GDC? So this is one that I can't actually name with a number because do you see how it's being split in the interior here? And I've got a number for each of those splits. So I don't have a single number that means this whole yellow angle. So this one I can't name with a number. The others so far we could. CDG. I can't see any other names that we could give to this one. All right, so before we move on, we did this angle. We did this angle, so the red one, the blue one, the purple one, the yellow one. I'm going to erase this here in just a minute, but do you guys see any other angles that we could make that have D as the vertex? D is the pivot point. Sylvia, you see one? What do you see? CDH. Oops, let me erase all of that. So I'm going to start at C, come up to D, and go over here to H, angle CDH. Is there another name that I could give that exact same angle? HDC. Oh, I just realized that I forgot to put my ankle marking here. I see one more name that we could give that green one. 10. I can call that angle 10. I see a couple more angles that we could still make. I want another angle. I heard FDH. So from F to D to H, angle FDH. What else could I call that angle? HDF. What else could I call that angle? I can't call it 6 just because it's made up of 6 and 10 together. Is there another point anywhere on either of these two rays? I could call it BDH. Any other names? HDB. Nice work so far. I see a couple more angles that we can make yet. Does anybody see another one that we could make? We did HDC, we did HDF. Is there another one that I could make with ray DH? So if I have this as one side, again, we already did this one. We already did this one. What's another one that I could do? Sylvia. HDG. We can do this one. So angle HDG. What else could I call that angle? GDH. Angle GDH. Any other names that I could give to that angle? Angle 9. All right, there is still another angle that I see that we could make that has DH as one of my sides. HDE, right here. I'm running out of room. I'm going to have to put this up at the top. Angle HDE. What else could I call that one? EDH. Could I call that angle 8? Could I call it angle 9? No. It has to be just one number in the interior. There are 2 more angles that I see I could make here that are kind of tricky to look for. I'm curious if anybody sees them. CD, I didn't hear. CDA. So CD, the problem is that D is not connected to A. If I could draw that angle, or if I could draw that ray in, then yes. I'm trying to just use what's on the figure right now, because otherwise I'm going to get real confused. BDC. Let's see, I thought we had BDC. Yep, BDC right there. CDE. That is a straight angle. Yes, we can do angle CDE. Or that could also be angle EDC. Do you guys see another straight angle that we could name? FDG, sorry. Angle FDG. Or angle GDF for this straight angle. Those are all the possible names that I can think of giving to every angle that has D as the vertex. All right. Question B. We want to name the sides of angle 2. So here's 2. The sides of my angle are made up of rays. What are the 2 rays that are making up angle 2? BG. So BG, remember when I name a ray, I have to start with the end point. So that's the same thing as my vertex. So B is my vertex over to G, or I heard this ray right here, and I agree, but what would we call this ray? BA. And ray BA. Name a point on the interior of angle FDE. So FDE, this one right here. I'm going to go over that with black, I think, so that we can see it a little bit better. FDE. What is a point that is on the interior of FDE? A. What about on the exterior of FDE? G. Anything else on the exterior? H. Anything else? C. G, H, and C. What are the points that are on that angle? E, D, B, and F, not A. A is in the interior. So on the angle would be E, D, B, and F. All right, we're going to shut it down there for today so that I can pass back your tests. Your homework assignment is up on my screen. Tests were